Hey everyone, and welcome to our deep dive. Today we're going to be tackling cosmogony, which is the study of the universe's origins. But we're not just going to be, looking at stars and galaxies and stuff.
Right.
We're going to be looking at how the universe can be modeled like a giant cosmic circuit.
Yeah, it's really wild when you start to think about math holding the keys to the universe's birth. It's pretty amazing.
Yeah, and to make things even more interesting, we're going to be blending insights from ancient Chinese cosmology with some pretty advanced mathematical concepts. So get ready for a wild ride.
It's going to be a fun one.
So one of the things that really caught my attention in the source material was this idea of humans being like a cable or battery connecting heaven and earth in ancient Chinese thought.
Oh, yeah. Yeah.
What are your thoughts on that?
Well, it's such a powerful image,
Yeah.
that humans are like a bridge between cosmic forces, a conduit of energy. And it's amazing how this ancient idea resonates with the concept of interconnectedness that we find in so many philosophical and spiritual traditions all over the world.
Yeah, it's really interesting.
Yeah.
So, okay, we've got this ancient idea of humans as energy connectors,
Yeah.
but then the source material throws us a curveball.
Okay.
It introduces this whole mathematical framework of two fundamental frequencies, e to the I omega t for time moving forward, and then e to the negative I omega t for time moving backward.
Mm.
Now, I'm no math whiz, so
Yeah.
can you help us understand what this actually means?
Yeah.
Because this sounds pretty complex.
Yeah, so it does sound complicated at first, but to understand this, we need to dip our toes into the world of complex numbers.
Okay.
And essentially, these numbers can represent oscillations like waves.
Right.
So think of it this way. These numbers, they let us mathematically describe the way things vibrate or oscillate in the universe, similar to how light or sound travels.
Okay, so I'm starting to see how waves could tie into the bigger picture of the universe.
Yeah.
But how do these specific frequencies, these building blocks, actually create, everything?
Well, that's where it gets really interesting. The source suggests that the universe might have emerged from a fundamental vibration or wave function. So imagine these two frequencies, right, representing time moving forward and backward as the base notes of reality. And then it's the variations or distortions on these base frequencies that could have created all the structures that we observe in the universe, from tiny atoms to massive galaxies.
So it's like the universe is this giant symphony.
Yeah.
With these frequencies as the fundamental notes and the variations
Yeah.
are creating all the different instruments and melodies.
Yeah, it is a beautiful analogy, isn't it?
That's pretty mind-blowing.
Yeah, it highlights that the universe might be built from this set of simple, elegant principles that give rise to incredible complexity.
Yeah, so where do we actually see this mathematical framework in action? Is there any tangible evidence of these frequencies and their influence on the universe?
Well, the source provides a great example. Elliptical orbits remember Kepler's laws of planetary motion. Well, it turns out that those laws, especially the elliptical shape of orbits, can be described incredibly elegantly using complex numbers and these fundamental frequencies.
Wow, okay, so we're seeing these mathematical principles at work in the orbits of planets.
Yeah.
But what about the bigger picture?
Yeah.
The source also talks about the void and this whole concept of finite versus infinite reality. And this is where I really start to get confused.
Okay.
If the void is infinite, how can something finite like our universe expand into it?
That's a question that trips a lot of people up. It comes down to how we visualize infinity.
Okay.
So picture a drop of ink expanding in a boundless ocean. The ink drop is finite, right? Yet it can spread indefinitely within this infinite ocean.
Okay.
Similarly, our universe can be finite and still expand within the infinite void.
Yeah.
It's not about the universe pushing against the edges of the void, but rather existing and expanding within it.
Okay, that analogy helps.
Yeah.
But then there's this discussion about language and information theory in the source material.
Yeah.
What does it mean that the void might be infinite, but language is finite?
That's where it gets really interesting. The fact that language is finite suggests that there might be a limit to the number of building blocks that we have for describing and understanding reality.
Yeah.
It makes you wonder if there are things about the universe that we might never be able to fully grasp simply because our language isn't equipped to handle them.
So our language might be like a set of tools, and there might be parts of the universe that we just don't have the right tools for yet.
Exactly. It's a thought-provoking idea, isn't it?
It really is. And then the source throws in the ideas of Georg Cantor in his work on different sizes of infinity.
Yes.
How does that relate to this concept of a limited language of the universe?
So Cantor revolutionized our understanding of infinity by demonstrating that there are different levels of infinity, some are larger than others. He did this by distinguishing between countable and uncountable sets.
Wait, hold on. Countable and uncountable infinities. Can you, like, break that down a bit further? Because that
Uh,
sounds a bit paradoxical.
Sure. So imagine the set of all natural numbers, like 1, 2, 3, and so on. You can count them even though they go on forever. Right? That's a countable infinity.
Huh.
Now imagine the set of all real numbers, including all those decimals that go on and on, without repeating. You can't count those in the same way. That's an uncountable infinity. It's a bigger type of infinity.
So even within the realm of infinity, there's a hierarchy of vastness.
Exactly.
But how does this connect back to the idea of a limited language for describing the universe?
Well, think of it like this. Even though the void might be infinite, the set of building blocks or fundamental elements for constructing reality might be limited in some way, and this limitation could be reflected in the language we use to describe the universe.
This is definitely making me rethink how I view the universe.
It's pretty wild.
And to make things even more mind-bending, the source throws in this fascinating fact. If you randomly select a point on a line, it's almost guaranteed to be an irrational distance from the starting point. What's the significance of that?
It highlights the prevalence of irrational numbers in the fabric of reality. So irrational numbers like pi or the square root of 2 are numbers that can't be expressed as a simple fraction. Their decimal representations go on forever without repeating, and this prevalence of irrational numbers suggests that the language of reality might be inherently complex and nuanced.
This is all so fascinating. We've covered so much ground already, but there's still so much more to explore. Join us in part 2 of our deep dive, where we'll continue to unravel the mysteries of the cosmic circuit.
So yeah, picking up where we left off, this idea that irrational numbers seem to be favored in the universe, it really makes you wonder about the nature of reality. It's like as if the universe itself has a preference for complexity and like endless variation.
It's definitely a lot to wrap your head around.
It is.
It makes you feel pretty small in the grand scheme of things. But let's go back to this idea of the universe as a circuit for a moment.
Okay.
The source mentioned that ancient Chinese cosmology saw humans as a sort of conduit between heaven and earth. How does that fit into this idea of a cosmic circuit?
So think of the universe as this vast interconnected web of energy, right? And in this view, humans, with our ability to like perceive and interact with the world around us, we become like nodes or connection points within this circuit.
Oh, yeah.
We're not just receiving energy and information from the cosmos, but we're also contributing to its flow through our actions, our thoughts, and even just by existing.
So we're not just passive observers of the universe. We're active participants in its unfolding.
Exactly.
I like that perspective, but it also makes me wonder if the universe operates like a circuit. What's powering it? Where does all this energy come from in the first place?
That's the million-dollar question, isn't it? And it's one that physicists and cosmologists are still grappling with. Some theories propose like the existence of a fundamental energy field that permeates all of space-time, a kind of cosmic battery, if you will.
Okay.
Others suggest that the energy might be inherent to the fabric of space-time itself, arising from like quantum fluctuations at the smallest scales.
So we don't have a definitive answer yet, but the possibilities are certainly intriguing.
Yeah, definitely.
But here's something else I've been thinking about. If the universe is a circuit with energy flowing through it,
Yeah.
does that imply there's a purpose to it all? Like, is the universe heading toward some ultimate goal?
That's a really deep philosophical question. Some might argue that the universe's purpose is simply to exist to unfold according to the laws of physics. Others might see like a directionality in its evolution, a tendency towards increasing complexity and consciousness. There are no easy answers here, but it's certainly a question worth pondering.
Yeah, I agree. It's definitely something to think about.
Yeah.
Okay, let's bring it back to the mathematical side of things for a bit.
Sure.
We've talked about complex numbers and how they can represent oscillations.
Right.
How do these mathematical concepts actually help us understand the circuitry of the universe?
So imagine energy flowing through the universe like an electrical current. We can model those flows using mathematical equations, much like we do with like electrical circuits here on Earth. Complex numbers with their ability to represent oscillations become incredibly helpful in describing those energy flows and how they interact.
So are we essentially talking about a cosmic version of Ohm's law or Kirchhoff's laws, but applied to the very fabric of reality?
That's a fantastic analogy. We're using the same principles of mathematics and physics to understand energy flow at both the macroscopic and cosmic levels. And what's even more mind-boggling is that these same mathematical concepts also apply at the subatomic level in the realm of quantum mechanics.
It's amazing how these different areas of science are all converging, pointing towards this deeper understanding of the universe's underlying structure.
Mm,
But let's get back to these two fundamental frequencies representing time moving forward and backward.
okay.
Does that mean time itself might be more complex than we perceive it? Could there be multiple dimensions of time or even time loops?
That's a really fascinating area of exploration and one that physicists are actively studying. Some theoretical frameworks like string theory and loop quantum gravity suggest that time might not be as straightforward as our everyday experience would lead us to believe. There could be additional dimensions of time, or time might even be granular, existing in discrete packets instead of flowing continuously.
So our linear perception of time, with its past, present, and future, might just be one slice of a much richer multidimensional reality.
Exactly. Our brains might be wired to perceive time in a linear way, but that doesn't mean that's the only way time exists. The universe might be full of temporal complexities that we're only just beginning to glimpse.
This is also mind-boggling. I feel
Yeah.
like we've fallen down a rabbit hole of cosmic proportions.
I know it's a lot to take in.
But let's shift gears for a moment and talk about those perturbations or distortions that you mentioned earlier.
Okay.
How do those fit into this grand cosmic circuit?
So think of those perturbations as like ripples or disturbances in the flow of energy through the universe. These disturbances could be caused by a variety of factors: the interactions of fundamental particles, the movements of massive objects like stars and galaxies, and who knows what else.
So are these perturbations just random occurrences, or is there some underlying pattern or order to them?
That's a question that scientists are actively investigating. Some believe that these perturbations might be governed by like deeper laws of physics that we haven't discovered yet, while others suggest that they might be inherently random, stemming from the probabilistic nature of quantum mechanics. It's a mystery that we're still trying to unravel.
It seems like there's always another layer to uncover, another mystery to solve.
Always another layer to peel back.
But how do these perturbations actually lead to the formation of the structures we see in the universe? Planets, stars, galaxies, and even life itself.
It's kind of like dropping a pebble into a perfectly still pond. You create ripples that spread outward, disturbing the surface. Similarly, these cosmic perturbations might act as seeds for structure formation in the universe. They create areas of slightly higher or lower energy density, and over billions of years, those subtle variations can get amplified by gravity. This leads to the formation of stars, galaxies, and all the other structures we observe.
So we're talking about a kind of cosmic ripple effect where tiny disturbances can have enormous consequences over vast stretches of time.
That's exactly it. And it's through this intricate dance of perturbations, fundamental forces, and the laws of physics that the universe we know and love has come to be.
It's incredible to think about all the factors that had to come together to create everything we see around us. But where does consciousness fit into all of this if the universe is a giant circuit? Is consciousness simply a byproduct of its complexity? Or does it play a more fundamental role?
That's a question that has fascinated philosophers and scientists for ages. There's no easy answer, and the possibilities are both exciting and perplexing. Some believe that consciousness is an emergent property of complex systems arising from like the intricate interactions of matter and energy. Others propose that consciousness might be a fundamental aspect of reality, just like space and time, suggesting the universe might be inherently conscious or even self-aware.
Wow, a conscious universe. That's a mind-blowing concept. But if consciousness is indeed fundamental, does that mean it can actually influence the flow of energy in this cosmic circuit? Could our thoughts and intentions somehow shape reality?
That's where we enter the fascinating realm of quantum consciousness, a field that explores the potential connections between quantum mechanics and consciousness. Some interpretations of quantum mechanics suggest that the act of observation can influence the outcome of quantum events, leading to the intriguing possibility that consciousness might play a more active role in shaping reality than we previously thought.
So we might be more than just passive nodes in the cosmic circuit, but active co-creators of reality.
Potentially, yes, it's a pretty radical idea, but it's one that some serious scientists are considering.
That's a pretty empowering thought. But before we get too lost in the quantum realm, let's bring it back to the mathematical side of things.
Okay.
We've discussed complex numbers, but are there other mathematical tools that can help us understand this circuitry of the universe?
Absolutely. There's a whole branch of mathematics called topology that is particularly useful for understanding the shape and connectivity of the universe. Topology deals with properties that are preserved under continuous deformations like stretching or twisting, but not tearing or gluing. Imagine studying the properties of a rubber sheet. You can stretch and deform it, but you can't tear it or glue pieces together. That's the essence of topology.
Okay, I think I'm following, but how does topology actually apply to something as vast and complex as the universe?
Well, one of the most fundamental questions in cosmology is the shape of the universe. Is it flat, spherical, or something even more exotic? Topology provides us with the mathematical tools to explore these possibilities and to understand the connections between different regions of space-time. It's like studying the wiring diagram of the cosmos.
So topology helps us understand how everything is connected in this vast cosmic web.
Precisely. And it gets even more interesting when we consider the possibility of wormholes. Wormholes are theoretical tunnels that could connect distant regions of space-time. Topology gives us a framework for understanding how wormholes might be possible and how they could potentially allow for things like faster than light travel or even time travel.
Wormholes and time travel. Now we're really going down the rabbit hole.
Wild ride, isn't it?
But it's incredible to think that these concepts, which used to be pure science fiction, are now being seriously considered by physicists.
It's a testament to the power of mathematics and theoretical physics to push the boundaries of what we think is possible and to open up new realms of understanding. It's an exciting time to be exploring these big questions.
It certainly is. We've covered so much in this deep dive already, from ancient Chinese cosmology to complex numbers, consciousness, and even the mind-bending possibilities of wormholes and time travel. But there's still more to explore. Join us in part 3, where we'll delve even deeper into the mysteries of the universe and the mathematical language that might hold the key to unlocking its secrets. Welcome back to the final part of our Cosmic Circuit Deep Dive. It's been quite a journey so far.
It has been.
From ancient Chinese cosmology to complex numbers, we even touched on the wild world of quantum consciousness. My mind is still buzzing.
Yeah, we've covered a lot of ground.
One thing I've been pondering is this idea of a limited language to describe the universe.
Yeah.
If our language is finite, does that mean there are things out there, aspects of reality that we just can't understand? Are there limits to what we can know about the universe?
That's a really deep question, and it's one that's puzzled philosophers and scientists for a long time. It's humbling to think that our finite language and our limited brains might restrict how much we can really understand about the universe. You know, there might be concepts, dimensions, whole realities that are just beyond our current ways of thinking.
So we're like those fish trying to understand what's happening outside the water.
Exactly. Stuck in our little pond, unable to grasp the bigger picture.
But that makes me wonder, is there any way to break out of that pond?
Well, that's the exciting part. I think we have to keep pushing the boundaries of our knowledge, explore new ways of understanding the universe. Just like those fish might evolve to explore the land, we might develop new tools, new concepts, even new languages that allow us to access deeper levels of reality.
Okay, so it's not a dead end, it's more like an open invitation to expand our horizons. But where do we even begin to approach these limits of knowledge? Where do we look for clues?
Well, I think mathematics might be one of our most powerful tools. It's often called the language of the universe.
Right.
And for good reason, it's through math that we've made some of our most incredible discoveries about the cosmos. By developing new mathematical frameworks and pushing the limits of the ones we already have, we might stumble upon hints of those aspects of reality that are currently beyond our grasp.
So math isn't just about describing what we already know, it's about opening new doors of perception.
Exactly. Think of it as cosmic code breaking, you know? By deciphering the mathematical patterns woven into the fabric of the universe, we might catch glimpses of things that are currently hidden from view.
That's a really cool way to think about it, but it also sounds incredibly challenging.
It is.
Where do we even begin to search for these hidden patterns?
Well, fundamental constants are a good place to start. These are like physical quantities, like the speed of light or the gravitational constant that appear to be fixed throughout the universe.
Okay.
Some physicists believe that these constants might hold clues to the universe's underlying structure, and that even tiny variations in their values could drastically change the nature of reality as we know it.
So by studying these constants, we might be able to decipher deeper layers of this cosmic code.
Exactly. Who knows what we might find? These constants could reveal hidden connections between seemingly unrelated areas of physics, or even point towards new forces and dimensions that we haven't even dreamed of yet.
This is all so mind-blowing. It feels like we're on the verge of this whole new era of exploration with mathematics as our guide through uncharted territories of reality.
It's a thrilling time to be alive, isn't it? Asking these big questions, the more we learn, the more we realize how much more there is to discover the universe is this vast, mysterious place full of wonders we're only beginning to comprehend.
Well, before we wrap up this incredible deep dive, I
Yeah.
have one last burning question.
Okay, shoot.
We've talked about the universe as a circuit with energy flowing through it.
Right.
But where does all that energy ultimately go? Is there an end point, a cosmic sink, where it all winds up?
That's a question that's tied to the ultimate fate of the universe, and cosmologists are exploring several possibilities. One scenario is the big freeze, where the universe just keeps expanding and cooling down, eventually reaching maximum entropy. That's a state where all energy is spread out evenly and nothing more can happen.
So a kind of cosmic heat death where everything just stops.
In a way, yes, but there are other possibilities too. Some theories suggest that the universe might eventually collapse back on itself in a big crunch, reversing the expansion and creating a new singularity, a point of infinite density and temperature.
So a cosmic cycle of expansion and contraction, death and rebirth.
It's a pretty mind-boggling concept.
It is.
But there are even more dramatic possibilities, like the Big Rip, where the universe's expansion accelerates so fast that it rips apart everything from galaxies down to atoms.
Wow, those are some intense possibilities.
Air.
It sounds like the ultimate fate of the universe is still very much up for debate.
Oh, absolutely. That's what makes cosmology so captivating. We're always pushing the limits of what we know, striving to understand the biggest questions about the universe, its origin, its evolution, its ultimate destiny. And while we might never have all the answers, the journey of exploration is what truly matters.
I couldn't agree more. This deep dive has been an incredible journey of discovery. I feel like I'm walking away with a renewed sense of awe and wonder about the universe and our place in it.
That's what we hoped for. To inspire curiosity, spark that sense of wonder, and encourage everyone to keep exploring the mysteries of the cosmos. Who knows what incredible discoveries await us in the years to come.
This has been an awesome conversation. Thanks for joining us on this exploration of the cosmic circuit. Until next time, keep looking up and keep asking those big questions.